Got a couple of co-organizers now. Looks like I'm the only one who's here, so I'm doing the introduction. And I just wanted to introduce the speaker, James Hodson. He's going to be talking about lesser-known problems in NLP. And I wanted to thank you guys for letting us use the space. And I think Zach here, who's with Bloomberg, is just going to say a few words beforehand. Thanks.
Thanks, Stuart. Welcome, everybody, to Bloomberg. Just wanted to say hello. My name is Zach Hain. I have been with Bloomberg for a long time, mostly in New York, and recently moved out here to San Francisco to start our new R&D office. So actually, we're hiring. I just wanted to shameless plug, put that out there. If anybody's interested in talking about that, or have friends who are looking for a new opportunity or something, come see me afterwards. I'd love to talk to you. Lauren, she's with our recruiting department as well. She can also help out with any information on that side. And without further ado, I will pass it over to James, who will be explaining about all kinds of very cool things that we do at Bloomberg. I hope you enjoy it.
Okay, so actually, I was originally going to talk about lesser-known problems in NLP, but since I had a wonderful journey up here from Palo Alto, I actually figured that all of you should be working on traffic problems rather than and so I actually appreciated it by the next time I come down here, somebody could figure out some interesting ways of managing the different traffic patterns. And actually, while I do this, that reminds me, I was at ETH Zurich a couple of weeks ago, and somebody showed me that you can get provable bounds on how quickly you can clear a traffic jam based on 2 or 3 very simple models of motion. So you have a few different models of how cars end up getting into traffic jams, and one of them is called the stop and go pattern, which basically happens when you have cars merging onto the, stop there. You can find out all of that online. But, okay, so very quickly, introduction to myself. I manage the knowledge engineering group, which is part of the Bloomberg Labs infrastructure at Bloomberg in New York. And my research group is split over London and New York, and hopefully in the not too distant future also in San Francisco. And we deal with problems in natural language processing, we deal with problems in machine learning, and we deal with problems in knowledge representation. So here is actually, this is a coaster from the Westin Palo Alto, and what it is actually, it's inverted, and then I drew on the back because at 3 in the morning yesterday when I was finalizing my slides, I thought, wouldn't it be nice if I could show people in a very succinct way what it is that my group does? So, obviously it's not perfect, so don't quote me on that, but it does have kind of that entrepreneurial feel to it that I was going for. So, the knowledge part of what we're doing is actually aiming at trying to get convergence over all of Bloomberg's data sets. So Bloomberg is this massive global company. We have access to thousands of different sources of information. In fact, probably every day I could talk to somebody new at the company and find that we're getting a data set that I had no idea that we would have access to. Just a few weeks ago, I realized that we had access to crop yields in particular South American countries, and that we were correlating that with weather patterns. I had no idea, actually a very interesting problem. What we deal with is building systems that will harness natural language processing algorithms, machine learning on structured graphs, and other kinds of structure that we can get. And knowledge representation, which is kind of how do we use this? How do we answer questions about the world? How do we organize this information to make it accessible in a way that will help people make decisions? And ultimately, how do we make things easier for our clients? But because we're a research group, we also try to give back to the community. So we have several open source projects that we contribute to and that we're actually planning to release soon. And we have collaborations across universities in the US, like Carnegie Mellon and Stanford, which is where I just was, Columbia, New York, and also over in Europe, where we have not only collaborations with universities, but we've been working very closely with the European Union on some grant proposals to do some very interesting scientific work in the areas of natural language processing, event extraction, and being able to represent what is happening in the world in a richer way than it's possible to today. What I'm actually going to talk about in this talk is some of the areas of natural language processing that have been that have had less focus placed on them over the last few years. So, in fact, if I go back to this slide here, one of the big things that I wrote is table understanding. Now, table understanding in the 80s and 90s was actually a huge topic. If you go back in literature and you see work by Bill Cohen at Carnegie Mellon, you see many students writing their PhD theses on table understanding. It was actually fairly well formalized at one point, but we were lacking the robust methods at the time to solve the problem. Today, if you go back in the literature, you'll notice that maybe at KDD once in a while you'll see a table extraction paper. You'll see a couple of PhD theses coming out of kind of middle-of-the-road universities on a yearly basis. There's not much work in that area, but we haven't solved it. You can't go and purchase a solution to table understanding that's actually going to extract you a semantically well-formed understanding of the table that you get, whether it's in text or HTML or PDF or an image. Right? There's no product out there that's actually going to solve that for you. But from an academic standpoint, it's kind of fallen to the wayside. So we try to take problems like that and revive them a bit and try to formalize them so that the research community will become interested in tackling them again. And actually that's a very interesting problem because actually I have kind of some friends over at Google, like Evgeny Gavrilovich's group and Kevin Murphy and those guys who at NIPS last year revealed not on purpose that they were working on exactly the same problem. So it's not as forgotten maybe as I was making it out to see. So here are the things I want to cover today. News is a clean source of text. So again, when we work with text, we often think of the pen tree bank, right? We get some nice syntactic parse annotations on there. We think of the Brown corpus for the part of speech tagging. Maybe we think of various other well-known corpora for solving things like tokenization. There's the message understanding corpus for, well, novelty detection, topic tracking, and so on. But what does it mean to work with news, right? Because as a news organization, in part, Bloomberg has access to a huge number of news stories every day, right? And we work on them in a streaming fashion, and we see things from every provider you can imagine. And it's not as clean as we've brought up to think that we can treat it. I also want to talk about what it means to find new information. What does it mean for something to be novel? What does it mean for something to not have been seen before, or for it to have the potential to cause changes in whatever universe we're dealing with? On top of that, I mentioned kind of our EU project. So if you want to look up online, there's an EU project that we've been working on over the past 3 years called XLike, Cross-Lingual Information and Knowledge Extraction. And you can see on there all of the different deliverables that have come out of that. One of them is, how do we actually model how people use news to convey information? How does the message change depending on the emotional state or psychological state of the author? How does it change based on what people want to achieve, the incentive structure of the person writing the text, and of the audience who's going to consume the text? And how authoritative are certain sources? So can we see over time that sources that people flock to tend to be more consistent in their coverage of certain kinds of news? Another area that you don't see much work on is normalizing language. So again, if you go back 30 years ago, everybody was talking about how do we model the sentences that we see or the documents that we see and normalize them into a more regular language, into a simplified English or a simplified German or Chinese or whichever language you want to work with. How do we make it simpler for the machine to pick up the same propositional structures as we wanted to without incurring the burden of very, very complex dependencies and long sentences and difficult to parse. And this leads actually directly into another area where we want to talk about named entity disambiguation, but we often think about NED from the perspective of, can we identify that when we say Manchester, we're talking about a football team versus a city versus a local authority versus a hockey team or whatever else. Here, we want to talk about it when the people writing the text don't want you necessarily to find out what the entities they're discussing are, or where they're changing them very often, where they use colloquialism, where there is a need potentially for mean tracking or identifying how these things are changing over time. Propositional structure is also very interesting because we talk a lot about interlingual, we talk a lot about taking text and turning it into something that is more structured, that has a formal logical backing. And again, up until now, how do we do that? Well, maybe we extract entities, maybe we try to find the relations between them by looking at verb structures and we try to characterize them. Berkeley's not too far away and we have the FrameNet project there. So how do we get towards a structure of language which is able to understand text in a more formal way? And I want to end the talk by talking a bit about moving beyond just using n-gram or shape features in text and actually trying to use the entire context that you have available in your problem. If I hadn't been writing my slides last night, I probably would have added a few more slides in here to go into more depth on what I mean when I'm talking about feature selection, when I'm talking about understanding the problem in a broader context. But hopefully these topics will be interesting enough to get us started. And the idea behind this is that if you have a question, if you want to make this more interactive, just shout out to me. I much prefer to have a conversation with people than to be lecturing for an entire hour. Although I do that pretty often, so I might have a lot of bad jokes that I can fit in now and again to keep everybody on their toes. So just to get started, yeah.
Sure, on that note. In the previous slide, there's nothing that mentions multiple languages. So is there any multilingual aspect to all of this, or is it all just
You're absolutely right. And up here I put machine translation, right? And I've got language modeling, I've got language detection, and all of these areas. So my group actually works on 15 different languages, right? So we care about building an NLP stack for all of those languages. And I will touch a little bit upon some problems that are cross-lingual. But I'm not going to go into much depth on those, but hopefully it will give you an idea that when I'm talking about these problems, I'm not only interested in solving them for English, I do want to solve them across all languages. And obviously if we're talking about extracting a propositional structure and building an interlingual representation, ideally we can do that in more than just English, otherwise why not use English as the representation. So, just so that we're all talking about the same thing, when I think about machine learning problems, and when I think about how I'm going to solve the problems that Bloomberg has with respect to its language data and time series data and weather and whatever it might be, I try to think a bit about the human context behind it. How would a person break down this problem and try to figure out the evidence that they need to make one decision over another? So I thought I would very quickly put something up here that would try to bring that up. What are the contextual clues? What are the pieces of information, of evidence that we can dig out of our problem representation, out of the space that we're looking at, that will help us to make a decision? And actually this plays a lot about, my background was also a bit in intercultural communication and translation. I got into NLP, back when machine translation was cool, and people were building these syntax-driven models, and before Philip Kern decided that everything had to be a phrase-based model. And we also used to think about, how do people actually communicate? What does it mean for me to say something and for your mental model to be able to understand what I've said in a meaningful way? And that's still a very interesting question when you think about any natural language problem. When I write a news article, I am trying to evoke some response from you. I'm trying to convey some information. And the way that I do that is important. The style that I adopt and just the context that I'm in and the way I make you think about certain topics is going to change the way that you understand it. Okay, so when we think about news, we think about well-formed prose, we think about the Dow Jones text that was selected specifically for that particular section of the Penn Tree Bank. And in reality, what we see, if you take just a cross-section of the 100,000 plus sources that we look at across the world, and roughly it's about 1.3 million stories on average a day, but they get up to 1.5, and it was around the number, so we'll put it up here. We get everything in here. We get poorly spelled news stories from campus newspapers. We get bullet-pointed lists where the editors wanted to be very fast in getting information out there. We get ASCII art in place of tables, so we get very strange spacing, and we have numbers mixed in. We have HTML where instead of somebody actually using table tags to lay out a table, they use table tags as kind of pretty printing formatting tools, so that they will have 26 real columns in terms of table tags, and they will have only 7 logical columns in terms of the data that they're passing around. Right? So we have problems like that. Sometimes, actually, the text that we receive is not meant for human consumption, it's meant for a machine to consume. So it has special tagging and formatting, potentially a PDF or an image instead of being text. So we deal with a whole cross-section of difficult to parse text. Right? You can't just start, when you're talking about building an NLP algorithm, from the assumption of receiving clean text, because then you're missing probably more than half of the problems that we have to deal with on a daily basis. So yeah, it's a lot of noise. It's a lot of noise, and part of the reason is that even if we had well-formed English text coming through, and English, we have a lot of resources to solve these problems, these are 2 semi-randomly chosen sentences from Bloomberg news stories. Okay, and if you read through them, what you'll notice is that they're incredibly long. In fact, you don't have to read through them, you can just look to see that they're incredibly long. They have a lot of interesting dependency structures, they have a lot of prepositional phrases, and they try to explain a lot in each of these sentences. They try to give you quite a bit of background on the company, on where they're based, on what they're doing, and because of that, these sentences, if you apply a syntactic parser to these, like Stanford parser, or ZPAR, or any kind of modern syntactic parser, they will do fairly poorly. And that's because usually when the parsers were trained, they would have a cutoff on nothing longer than 30 or 50 words. And if you end up having a sentence that is 70 words or 80 words, then obviously it's not going to do too well. But even when you're trying to extract relationships, okay, the relationship structures, when you have a sentence of this kind, become all of a sudden much more complex than having subject-verb-object relations, right? This is a lot more difficult. And we don't do very well on this still in the state of the art for these problems. Okay, so now informal news text, so we're talking about social media, right? Social media, we assume, well, that's actually a difficult problem, right? So we have a lot of people working on parsing social media, building corpora so that we can apply special neural language models to social media so that we don't have to start defining new part of speech tags for it. And that's one side of it, and sure, there's a lot of it. Actually, having a lot of it can be useful because then we can maybe concentrate on some less granular features, like we just extract some entities that are fairly easy to get and then track those over time. But if you look at other kinds of social text, like blogs, actually, I found this, again, this is at 4 a.m. and I'm surfing the web trying to find examples for the slides. This is from yesterday. And it's quite fun. But you see, the way it's being written, again, it assumes a much more colloquial tone. It's much more informal than you would see on the previous page. And if you go through them, when people are writing, there are these large hidden assumptions that they're making, which to a dumb algorithm, or even a smart algorithm, if we can get there, are difficult to understand. There's missing information. Now, here is actually one of the things that I like to tell people, because there is really very, very, very little work on headlines, okay? So if there was only a little work on table understanding, there is no work on headline understanding. And guess what? If you're in the finance industry, or if you're working in any kind of with company information of any kind, and you care about when things are changing during the business day, the information comes out as a headline. It doesn't come out as a news story. It always comes out as an all-caps headline. And the reason is that organizations like ours, like Dow Jones and Reuters, have teams of dozens, if not hundreds of people who are trained to stare at screens, be on the phone, find information, and turn it into an all-caps headline that fits into a 64-character blog. And they're not consistent. They're not going to make the same abbreviation each time. It depends on the context around it and how much space they end up with when they reach the end of the line. You know, sometimes it has bizarre stuff in the middle of it, like this 8363. So on the other side of it, it's written for experts. So it's written for people who spend their day staring at a scrolling headline of screens. And if you think that's a job of the past, well, you should probably ask Zach to take you on some client meetings or something and see how their setup is when they use the Bloomberg terminal, because a lot of people are still getting their information and making decisions about their work and how they interact with their portfolio or with the decisions they make that impact companies by staring at screens that are flowing through. So if we can understand these, we can unlock a lot of information. We can unlock it faster than you're going to get it in the New York Times or the Wall Street Journal and in other places, right? This is actually where the important information is. And again, like if we, to your question about multilinguality, that's okay if I'm doing it in English. Now I've defined some great problems for the English language, but it's not the same when I'm talking about other languages, right? I was talking to some German editors about 18 months ago, and I said, look, we want to make our German statistical translation engine better than it is currently, and we know that we do very well for financial domain translations, but we would like to add in more news-based stuff on general company news. And I said, well, for that I need parallel data. I can build a very large language model which will give me good syntax on output, but I need parallel data so that I can learn a translation model between the two languages. And the German editor said, no. You see, the problem is that German is not written the same way as English. You can't translate an English story into German. That's absurd. When you want to write English news in German, you have to rewrite it completely. It's a different structure entirely, right? It's not just about the verb going to the end of the sentence at the appropriate time. It's actually that we don't write about concepts in the same way. We have to move things around. We have to give more context. That was actually a conversation that I had. In Italian, half of the sources omit the accents on the letters. So if I train, a nice language model and I have clean data for doing that, and then somebody sends me, some text without any accents in it, actually in Italian it can be genuinely ambiguous quite frequently. Things that we noticed, like US events have more background provided in foreign language news than they'll have in the English version. French news stories are longer. This has actually been known for years. Like the French prose is about 30% longer than English. Go figure, right? It's not because each of the words is longer. It's just a fact of the language. And in Japan, well, there are some cultural or contextual issues that are taking hold. The important information comes out at 8:30 or 9 a.m. when the market opens. Okay, that's different from what is the text saying. That's actually a contextual understanding thing that we have to know about. And sure, of course, like most sources come from English-speaking countries. English-speaking countries still have a much higher density of news providers than non-English-speaking countries. Or specifically, the US and Europe has more English news outlets than other countries have their own news outlets. So, because of this, because of the German editors, I have less training data for machine translation, which is a pity. Now, I talked about novelty detection. So we would like, ideally, if we're processing a stream of 1.5 million news stories a day, rather than have somebody read all of those news stories and decide which one is important for them, or set up some complicated searches on the topics or the companies or the people or the locations that are being mentioned within them, it would be great if we could surface those things that are most important. Okay, so now one issue with this, or one drawback of this, is that people don't necessarily only react to new content. So we got the paper by Tetlog in 2011 that showed that, actually, and there are several problems with this paper, so I'm not going to talk about it too much, but he showed that if you took duplicate information, so information that was known to the market and that the market reacted to, and you identify it later as it's coming out, that duplicate information, so exactly the same text as was published before, would continue to have a market effect later. So on reading duplicate news, investors would react either positively or negatively and overreact to that original content. So earlier this year, actually this is my wife, so this is actually, it's me and my wife publishing together. We looked at whether it was just duplicate information or if it was duplicated versus aggregated. So if I have 3 stories that came out in the past and now I publish a wrap that summarizes all 3 of them on the same story, maybe that has a bigger impact, right? Because now all of a sudden the investor is looking at it and they're saying, oh, well, I saw each individual piece of news, but now that I'm seeing them together, it seems a lot more significant. So it turns out actually that is the case. So if you take 3 pieces of information that were published separately before, and you put them into a new story, you can get people to react to that even more than they react when they see the same news over and over again, right? Of course, that same effect will reverse on the next business day. So these are all overreactions, and then people eventually will revert to the mean. And it's a consistent behavior that we've observed since 2000. So people have been inconsistently overreacting to news for a long time. So that's a little caveat to how information get absorbed by the market, or absorbed in general, right? I'm using the financial market as a microcosm here, but think about it as anybody who is reading the news and reacting to what they're seeing. All right, ultimately, these small interactions all bubble up and come together. So newness is not an inherent property of the text. What do I mean by that? I mean, often, and if you look at a lot of the research that came out of University of Edinburgh a few years ago on novelty detection, and actually, it was good research. I just hired the professor at University of Edinburgh that worked on it. But if you look at the work that was being done at Edinburgh, it's all based on only the text of the article. Okay, so I receive an article, I look at it, and if any of that text has occurred before, either based on topic distributions or based on distributions of verbs and entities and maybe even propositional structures if we have some parsers that we can depend on, it's based on the text of the document. But when I'm reading this news story, how do I know that a new piece of information that's being made available is actually new or important? So the fact that Iron Mountain is Boston-based, if that hadn't been mentioned before, it doesn't actually make it new. right? Iron Mountain has to have been Boston-based when it was founded, otherwise it wouldn't be Boston-based Iron Mountain. Maybe they moved, but still, you get my point. So we need a lot more information than just the text of the story in order to be able to make any sense of whether something is novel, important, impactful. IBM's shares jumped 3% during market open today. Okay, this is something I pulled from Twitter a few weeks ago. Well, okay, so great. Now I pull out that IBM, the company, and had a jump in price, a spike in price of 3% today. Okay, so is that new information? Or what if or maybe I can resolve today to today, and if it happened yesterday, it's a different event. But, with most of the approaches that are fairly shallow, I'm not necessarily going to capture if IBM jumped 3% 2 days in a row. So as I mentioned, we have a lot of information in the text, right? If I give you a piece of text to read, you will most likely be able to pick out if there are really hard-hitting things in there that potentially people did not know about before or have been made explicit in a way that they weren't made explicit before. However, you need more than that in order to be able to build a novelty detection system. You need more than that in order to identify how important a piece of information is going to be. So, in order to do this, how do we do it? Well, okay, so we're scientists, we like to build experiments, and we like to be able to verify that what we've done to some degree achieves a certain problem. So, novelty. Let's say we give somebody the text, and maybe we even give them access to some information about the companies and some stuff that's been happening recently. Then this becomes, well, we want to build a corpus because that's how we're going to learn to do this task with an algorithm. So it becomes a fairly simple sequence labeling task, right? You read story 1, and then you read story 2, and you read story 3, and if story 3 is the same as story 2, then you would mark that as not novel. If it has information in it that you haven't seen before, then you can circle that information, and eventually you build a corpus. Now the problem is that that's great if you want to do 10 documents, right? Not so great if you want to have a corpus of 100,000 documents or 1 million documents. So if you're using, the message understanding corpus for this particular problem, then you're going to be solving the problem from a topic distribution perspective, right? You're going to say, well, this mixture of topics did not appear before. What you're not going to be doing is saying this fact or event or relationship in the text, this particular structure was not made evident to me before. And we would like to do that. We would like to actually be able to evaluate on a micro-reading level. And when I say micro-reading, I mean looking at the phrasal structures rather than looking at the document as a whole. And macro-reading would be just concentrating on the document. I want to do it on a micro level, and I want to be able to learn all of the features that exist in the document that might help me to make that decision. And then I want to marry them with high-level features about the context and how things are changing and how these entities have been moving in the past to make a better decision. So what we came up with was actually, and this is kind of a working paper that we're about to publish, or well, hopefully to have accepted somewhere, is that basically let's just have a pool of 100,000 documents that we want to annotate, and let's filter them by the kinds of topics and entities and structures that we're finding within them. And then we will have kind of clusters, cross-temporal clusters within this pool, and we want to choose at random pairs from common clusters. And we're going to show these pairs to people, and we're going to ask them, well, is there overlapping information in these documents? Is there something that is new in here, or kind of sounds new? And we're going to start to kind of do the opposite task. We're going to say, well, this is the same as this other thing. And we're going to find common areas between the documents. Now, we can achieve kind of, we can get the problem with enough pairs to have bounds on our confidence that we've covered the relationships that existed between the documents in this corpus. And that is a much more tractable problem, not computationally, but from a human perspective, than it is to have them read and memorize 100,000 news stories and identify all of them. So this is how we're currently going about building a 100,000 document corpus for the novelty detection problem at the propositional level. Okay, so yeah.
And you're successfully using Esther for that? Yeah, for a question mark. Or are you still
Successfully. What does it mean to use Mechanical Turk successfully? So what we found is we have a team internally of annotators who have built a smaller corpus that we interspersed during this. So they worked on 10-hour time slots, and this was a 10-minute time slots, and this was a one-day corpus. So we took 100,000 stories in particular verticals that we cared about over an entire day. And kind of within those slots, we just embed them into the tagging, and we try to check that they're doing a reasonable task. So far it's okay. It's not ideal. Right, so the intuition that you can do this at all is what I was driving at, rather than the intuition that Mechanical Turk would be the right way of doing it. But yeah, it's an open problem. It's not something that we've solved. We don't have a corpus yet, and we haven't tried modeling anything with that corpus. So open questions. Yeah. Yeah.
So do they just add tags? Or what do they,
Yeah.
would they say something, would they tell you that the Boston base is not important?
No, so what they do is we have an annotation tool. So you can also, it's an open source annotation tool. It's called BRAT, and we've hacked BRAT to be able to auto tag a lot of the story with the structures. So we have our own internal pipelines for event and relation extraction and disambiguation, and we essentially ask them to kind of highlight the kind of the things that are similar between the documents, and then we learn by having many pairs of these documents the things that we want to know. So it's a semi-automatic annotation task. Right. And if any of you guys are interested in the BRAT tool, there are some modules that we're going to be adding to that project in the near future that make it very easy to automate the task of tagging in the background, so you can render people a lot more efficient if they're using that tool for tagging than if they're using other tools. Yeah?
What do you think, or what have you found to be a good threshold for this model? You said some threshold, so I'm kind of curious what that threshold is.
Some threshold for, sorry.
Can you correct the previous slide?
Yeah, sorry.
What is your some threshold?
Yeah, well, some threshold, so you can choose, like, do you want to be 95% confident that you haven't missed any relationships in these documents? Do you want to be 90% confident, 80% confident? So, I mean, we would like to be, ideally, we only want to accept a threshold of 5%.
Okay, that's pretty much what you guys found.
Yeah, but we haven't found that empirically. That was something that I decided at some point that I thought was right, but it probably should be subjected to more rigorous experimentation. Yeah.
Is there a high marginal cost of how many pairs does it take sort of to push your threshold?
Millions.
I realize that, but how does it scale sort of for every extra percent? What's the marginal?
Okay, that's interesting. Yeah. So obviously it's not linear.
Right.
But it's not exponential either. So I don't know the exact number, but it's going to be in the paper. I can't remember it off the top of my head right now. I'm sorry. Fine. It's let's see. We ended up wanting to do something like 6 million individual draws. And that didn't cover the full 100,000 in practice. We ended up scaling it back even more. But already 6 million is a fairly big outlay of fairly big investment for something that you don't know whether it will actually yield a corpus that's usable. So, but we pay very little, so it's doable. It all depends on how long you want to wait for Crowdflower or Mechanical Turk to complete. Anything else on this? Okay, I get the feeling that people are kind of a little bit interested in novelty. Yeah?
Is this for building like a background model for your domain, or is this for exploring new relationships?
This is, so, okay, rather than trying to learn domain-specific models through this, what I'm trying to do is to learn what kinds of features of the text represent newness, and where is the boundary between what we can achieve with textual methods alone and where we have to actually pull in auxiliary information from markets, from past experience with the same topic or concept, and so on. Right. So in practice, I'm not sure to what extent we'll actually be able to directly learn a model of novelty from this corpus, and I'm not sure it would be any better than an unsupervised approach to novelty detection. Right. Ultimately, I guess if your disambiguation pipeline is perfect, right, and you can identify the relations and cluster them properly, then you don't really need a corpus because you should be able to pull out the same relations being discussed across text. But that's a big assumption. Yeah. Okay. So actually, this is kind of quick. In fact, I've got this story up here, but really what I wanted to have up here was the tweet from the Associated Press when their account got hacked, where they claimed that there was a bomb in the White House and Obama was harmed, or I don't remember the exact text. And ideally, we would have wanted that not to cause a plunge in the Dow Jones Index, which I think it did. I think it caused like a 3% move on that day. So how do we do this? So what we've been toying with is building specific lexicalized language models on a per source basis and a per region basis and a per author basis in some cases, that would characterize the kind of news that is being written by the different organizations from the different regions and provide you with a probabilistic measure of the likelihood that a particular news story was generated by that particular source. So what we found is that for more formal news, we get very, very good signatures for how the news is generated, the kinds of stylistic conventions that are being used, the topics that are being covered, and from the one hand, this is a production measure, right? So news organizations produce news, and that's not necessarily to say that they produce all of the exact right kind of news that people want to consume, but they produce it in some proportion over another. And what we can measure is if Bloomberg News happens to be publishing a lot about the US financial markets or commodities, more so than about sports, that probably Bloomberg News is a more authoritative source or knows more about or is more interested in these particular topics over others. And actually, the measure is a very simple query like you would measure from search theory. And if you cluster similar sources, you can start to categorize them into the sources that are more authoritative on certain topics. And if you have some hand-labeled parts, you can start to actually ask questions about, well, which ones would I want to actually go and read if I'm interested in getting a democratic perspective on this issue or another perspective on this issue. So this also plays a lot into the bias conversation. We've got some interesting work again with the X-Lite project, where we're looking at pairs of news sources on the same topic and trying to understand where the bias parameters lie. So if you've got Al Jazeera or Bloomberg News talking about the same attack in Syria, how are they talking about it? What words are the ones that are different, right? How are they characterizing it? Freedom fighters versus insurgents, attack versus defense, and so on. So actually finding interesting measures in that domain is something that's resurfacing right now in terms of the research that I'm seeing in natural language processing. This is actually something hopefully all of you guys have heard. You know, that Twitter is gaining a lot of speed in terms of where we're where news is being released first, right? So there are many instances where we show you that you saw it first on Twitter, and you know, people release their earnings on Twitter. Information propagates faster through the social networks, so you can get people to know what they need to know more quickly. Well, here's an example where Carl Icahn wanted to tell the world that he bought a large stake in Apple, and he felt, along with Tim Cook, that Apple was considerably undervalued. Right? He felt strongly that he should make money on this investment, and Carl Icahn is an activist investor. So, you know, obviously we want to be able to make money on an investment. If I'm an activist investor, I want to come in, I want to break apart your company, fire the people who are being not very productive, reshuffle the board, and split off any divisions that are doing things that they shouldn't be, and then make more money. Now, what Twitter is not showing you, and what Carl Icahn obviously probably doesn't want people to know, is if you look at the kind of inside market, actually the trades that were happening right before this, what you see is that there were trades originating kind of in certain fairly suspicious areas in like the 2 to 3 minutes right before this was released onto Twitter. Okay, so there was actually a spike in trading. A lot of people made a lot of money from the fact that Carl Icahn posted this on Twitter. And that brings up, well, you know, what is the incentive on Twitter to release information? What is the difference between the information being public or private when it comes to putting it on social media? What about if I put it on my Facebook account, right? Where does that line get drawn? People are often, especially when it comes to micro-publishing, where you have one person or a small group of people publishing, trying to achieve a certain goal by putting information out there. And if we're going to build algorithms that are robust to this, we have to start thinking about the problems of, you know, incentive understanding. So what is the incentive for somebody to put this information out here, right? As opposed to writing it all in their 13D filing when they get a more than 5% stake in the company and it goes through the regulatory process and people find out in the way that they're used to. Okay, so you know, some open questions there. How should we go about it? All right, so we also mentioned earlier, 10 minutes. I've got a few more slides. I'll try to speed up. So what I would like to do is, because it would make my life much easier for machine translation, it would make my task much easier for text categorization, it would make search easier and so on. I would like to take these long sentences that we've said modern NLP methods still don't work very well on, and I would like to be able to split them apart into shorter, simpler sentences, right? And I would like to disambiguate the concepts, and I would like to mark the co-references, and I would like to be able to understand them by pulling them apart. And so, you know, here I actually have somebody in my group who is did her research in paraphrase generation, and now she's trying to apply kind of an objective constraint on the paraphrasing so that it achieves kind of a syntactically more likely split in the sentence, especially these kinds of long Bloomberg news or Dow Jones news sentences. The smallest number of these kinds of relations that we extract between noun and verbs, and to try to minimize the number of complex propositions. So the number of propositions that include long-range dependencies in the sentence and multiple prepositional phrases. So this is just an example here, and we've been building, again, manually, more so, well, semi-manually, a corpus of broken down sentences. So from the original trying to break it down so that we can learn some of the interesting patterns about when to break things apart, when not to break them apart, right? And you can imagine that you can learn fairly interesting patterns around what kinds of verbs, like the transitive verbs, intransitive, what time, what kinds of arguments do they take that you want to split apart, and how do you go about doing that? And, you know, for translation, if you can push everything into simple English, then it makes our life much easier, because we might even then aspire to go up higher in this Vauquois triangle. If any of you are familiar with translation, we can go towards kind of semantically enriched translations. We can have tree-to-tree, and we can have more robust hierarchical methods, as opposed to just dealing with phrasal methods. And here's an interesting one. You know, this is, nobody's talked to me about garden path sentences since I had a linguistics class. And these are actually very, very interesting, because we work with Michael Collins at Columbia, and we work on building really, really, really fast syntactic parsers. So syntactic parsers that can parse hundreds of sentences a second at state-of-the-art accuracy, which is around 94% on pen tree bank right now. Receiving pen tree bank again. And, you know, we sat down and we started reading through some of the harder things that we wanted to parse. And we actually found that for the first time in our lives, we actually were reading text where we could identify garden path sentences every now and again in the news that we were reading. And, you know, I especially like the last one, fat people need to accumulate. But these are, you know, mostly, again, they're poor construction in the way the sentence was written, rather than any fundamental difficulty in representing the thought in the language. But when these happen, we should be able to normalize them. We should be able to choose the more likely, the more syntactically or semantically likely option between those two interpretations, so that we don't need to be worried about this. Right? Syntactic parsers especially don't have a great time with these kinds of formulations. In fact, if you could actually just take a picture of this, copy down these sentences, and then go online and take the canonical Collins parser from '96, and just run these through the Collins parser, and you'll see some very interesting linguistic patterns coming out of it. So here, actually, two more, just quickly. All right, I'm not running out of problems. I could go on for hours, but if you'll just give me a few more minutes. We want to be able to learn about boilerplate. Okay, so here it is. We've got news stories coming in, and it's a big problem for us. You know, our sentiment algorithms end up reading the end of the news story where the company is telling you how great it is. Right? And at the end of every single one of their press releases, it doesn't matter whether they're telling you that their earnings are down 50% for the quarter, or they've just, you know, hired the greatest scientists that ever lived, they're going to tell you how great they are. And then it's positive, right? Well, it's positive if your sentiment algorithm is shallow and it only looks at the text and it doesn't take account of context and it doesn't understand which items are novel and not novel. But this is a real problem, especially because often news wires will take news from other sources, they will wrap them in boilerplate of the form, you know, this news comes from here, or we're not sure about whether it's really true, we haven't corroborated any of it, and they will wrap that around, and then they will push that back out onto the wire. Okay? And when my wife and I were working on this aggregation paper in news, what we found is a lot of the early aggregates that we were pulling out actually just turned out to be people taking stories off the wire, wrapping them in boilerplate, and then pushing them back out. Right? And this was this was nested, so it was happening multiple times. So, you know, can we identify based on repetition across the news wires? Can we identify based on the kinds of language that are being used? When somebody is writing a very set, specific piece of language. Maybe it's positional, maybe it's language specific. And we obviously have done some work on this, and we have models that we use kind of day in, day out to try to identify boilerplates and strip it off, and some of it is rule-based and some of it isn't. But this is a problem where, again, if you are a master's student at Stanford and you want to get started on a problem in Chris Manning's NLP course, you're just going to go and you're going to download all the text and you're going to run your algorithm on it, and you've got some, validation set, and maybe you're going to do cross-validation, and you come out and you get a number and you submit it, and that's great. But you haven't actually solved the problem. You need to go in and understand what you managed to do. And boilerplate is one of those. Templates are another. Templates are a huge problem in the financial news because you have these providers that generate news based on the shape of the chart. There's one particular provider called Recognia. Recognia is a chart trading firm, and they developed this really sophisticated, intelligent algorithm that uses neural networks to tell you when the stock's going to go up and down, and they identify these shapes in the chart. And when they identify a shape, they send you out a pro forma news story with certain variables having been changed, right? So of course, actually, it turns out some people are interested in chart trading. Otherwise, if it were up to me, I'd just throw all of them out. But some people are actually interested in this, and we were marking everything as duplicate because it comes in, and if you look at text-based measures, everything was exactly the same apart from a couple of tokens. No, we have to be able to identify these forms, and we have to be able to apply them so that we can reverse engineer what has actually changed and extract the pieces that are most important in representing the difference. Okay. So again, these are, if anybody is looking for PhD thesis ideas, you can come and talk to me afterwards. I have hundreds. So, okay, actually this is maybe one of the more interesting ones, or at least it sounded more interesting on the original menu, and probably some of you are itching to leave, but you wanted to wait for this slide. So, name density disambiguation under adversity. What do I need here? Well, NED is hard, right? SIG-IR was on the Gold Coast in Australia a few months ago. And we had a workshop there with Microsoft and Google on disambiguation. And there was a disambiguation challenge, and everybody submitted their algorithm, and we're still not doing very well on disambiguation, even with kind of a canonical data set. Even when you overfit, you're still not doing particularly well on this problem. So, and if anybody is interested in NED, you can usually check out the AIDA project from the Yagonaga people in Europe, because that's probably the most promising one right now. Okay, so we want to be able to understand that Michael Jordan is talking about Michael Jordan at Berkeley as opposed to the basketball player, but if you type Michael Jordan stats into Google as of a few weeks ago, it will give you the basketball player because he has a lot of, has a lot of statistics. And that's probably a good thing for most people. Yeah?
Maybe you're getting there, I'm curious to sort of, what's your gut feeling about why these algorithms are so bad? Because usually there's some intuition to why you fail.
Absolutely. So, obviously I think my algorithm is the best one, which is actually, we developed an algorithm that uses the AIDA algorithm and adds a lot more coherence measure-based features into the algorithm. So AIDA looks, if you're interested, at the entire document so that each entity that it picks out is given a coherence measure based not only on its local context but also on the document context and on a model that gets learned from the Wikipedia context. Okay, so you have San Francisco, you have a Wikipedia entry, it's going to learn a model for the city of San Francisco based on that. It's going to look in the rest of the document and it's going to find if you have other mentions, what have you disambiguated to? Or it's going to basically give you the graph and it's going to San Francisco, San Francisco, San Francisco, and it's going to try to do a joint optimization on those so that it will give you, one representation ideally, unless they converge too much, in which case it will give you multiple indices. So the answer to your question is that we need to be doing more with non-local features, okay? Because humans do more with non-local features. As soon as you read text and you don't quite get which entity it is, you start digging around the rest of the document. You start digging around other documents that this guy has written, right? You start looking at what is trending right now. And eventually you figure it out, or you ask somebody with more expertise to tell you which one it is. Does that answer what you were after?
Sure. To which extent do people try this escalation sort of approach?
Well, right now, that is probably the biggest area of research for named entity disambiguation, right? In fact, so if we went through a phase where everything was being very highly optimized so that we get very fast disambiguation, and now kind of we put that to one side for a bit and we're saying, okay, well, can we solve it properly first? And then we'll figure out how to make it fast, right? Then we'll get some good engineers into a room, we'll write it in C++, and we'll get it to be fast. Now,
usually it is nonsense per discourse, right? Or that is.
Sorry, can you be a little bit louder?
Usually it is one sense of entity in a discourse. Or in the news world, is it very different from that? Or?
You mean it's one sense in an entire document for the same entity? Is that what you're saying?
I mean, that is at least like the prevailing heuristic used in product world.
Sure. I mean, it's a heuristic, right? It works until somebody comes along and writes a document that talks about San Francisco and the various sports teams within San Francisco that go by the same name, and they don't do a very good job of necessarily distinguishing between them. I would rather, so, you know, often when you're solving a problem in NLP, it's good initially to make some heuristic assumptions so that you can test what kinds of information might be useful and important for solving a problem. But ultimately, if you're going to do this in a scientific way, you should always use your features as features, not as kind of heuristic overrides. And you should be able to learn whether that's really important or not, and if it's generally true or not. And you might be right, it might be generally true, but I would hate to treat it as always true. So take NED and then add on top of it the fact that, so we have products that allow people, if they want, when they're trading bonds, because Bloomberg's messaging system actually turns out it's one of the largest bond trading platforms in the world. If people would like to have the information available when they send each other messages, then we'll scrape it. And we will make that available to them. And we will allow them to use it so that they can more easily find the particular offers that they were given, and they can categorize the people who they're trading with and so on. Bonds are completely, well, mostly over the counter still, right? So if you have a lot of the bond market trading in a messaging or an instant messaging application, then you need, obviously, in the 21st century, ways to help them keep track of that. You could say, why don't they just have an exchange, but that's beside the point. So the way that they write in here is every time they write something to come up with a new name to describe it. Right? It's very colloquial. It's like being on a trading floor. Like the names change on a continuous basis, depending on the weather outside, depending on what they're planning on having to drink after work, depending on anything. So the reason it's under adversity is because obviously these guys aren't doing it on purpose. They would like us to be able to give them a very clean output on what offers they were given and what they've been trading, but kind of in their spirit to try to throw us off. So if any of you are familiar with the work by Yuri Leskovitz at Stanford in the SNAP lab, you'll know about the meme propagation work that was being done. There's also, I think, Thomas Hoffman at ETH Zurich did some work recently on meme propagation. And this is like a time-restrained meme propagation problem? Like, how do you identify chains of these things over time, and how do you learn to identify them? Yeah. Question?
I guess my question is, how do you kind of Louis von Ahn approach these things? So in all of these things, like you're struggling to come up with tuning things and all of this stuff, and paying people, but you can't really pay them to do more than 10 and all of this stuff. And how there must be some way, like with the translation, you have the translations, which are your golden data. And what's something like you have already these sentences going down these terminals, and something like eyeball tracking or something where you can have a golden set for a significant, like more significant, for millions and millions of documents, and then it becomes a more standard problem. Yeah, have you thought about this line?
Yeah, so one thing you have to understand about Bloomberg is that we have close to 350,000 clients, each of which pay a huge amount of money each month so that we don't bother them with anything. And the moment we start asking them for input on any of our problems, they start to, rightfully so, think, well, why the hell am I paying you if I then have to help you solve the problems that you have? So you're absolutely right? We could be collecting data in more novel ways. But it would be very difficult for me to take a Wall Street trader and put like eye tracking devices on them. And actually, so in a previous life, I was at the DFKI, which is the German National Research Center for AI in Saarbrücken, in Germany. And there, with Philip Kuhn at Edinburgh, we had a lab where we would track people's eye movements over a screen, right? And we would pay these people to put on these tracking devices, and we would kind of see how they translated sentences by looking at where their eye movements went, how often did they look at the noun, the verb, how often did they look at the reference sentences. And we found that actually having these things on changed their behavior. So it was a poorly built experiment in that sense. Like it was difficult to control for everything.
Maybe changing their behavior is the right thing. So you have this huge worldwide news organization that people read, right? And if you structure the sentences in a certain way where people felt incentivized to click on the piece of information that was important to them to find out more about that, then you could understand that they don't care about Boston-based. I mean, the best would be if you could, if you had something right there that said buy or sell, and right. I mean, essentially, this is what you want to know based on which 2 or 3 words in the sentence do you want to buy or sell.
So I think you're onto that should I get exactly what you're saying. So obviously there are hundreds of ways or thousands of ways in which you can render the interaction and the data collection when this data is available more possible, given the users that you have. And you're onto something that we should obviously be exploring wherever possible, making it easier for people to share their understanding or opinion or usage of that data with us. So I think it's actually a very great insight. We have done that in some cases, so we have changed the way that we've written some stories in order to test whether people absorb the information more readily. What I was trying to do with this today is not really tell you that we have all of these problems, even though obviously we're working on these things. It was more to highlight general problems in natural language processing that are not getting as much attention as I think they should, given how much time we spend building name density recognition systems or syntactic parsers, right? Which are both systems which will give you very wrong distributions of information if you don't solve a lot of these problems first, right? It's very difficult to use those high-level systems unless you have a strong grasp on the real problem that you're trying to solve. And I was trying to highlight some of the things that I think are important. But when we go about actually solving them, we do explore kind of what you said, how can we get more of an experimental setup so that we know how people are behaving. And again, being married to a behavioral economist, I know what it's like to try to structure experiments in a rigorous way so that you incentivize people appropriately. It doesn't always work with our clients. There was another question, I think? Nope. Okay, so mean propagation. Oh, this is really cool. This is really cool. Okay, so you want to take some text and you want to automatically understand all of the statements being made in some formal logic, whether it's first order logic or some higher order representation. Now, ideally, whether I want a frame out of it or whether I want just a set of logical statements, doesn't matter for now, but here we clearly have a fairly straightforward sentence, right? So obviously I could template this and I could pull out the information fairly consistently. But we've been working with the guys at Psych Europe, and I don't know how many people are familiar with Psych here. Okay, so a few. So Psych basically have been building this massive ontology since, for decades. And they also have this language called PsycL. Now the great thing about PsycL is it can actually generate statements in plain English from the logical predicates. So what you can do is you can run over the entire ontology or the area of it that you care about, and you can generate these statements in English. And what we did with, and actually so Psych is another partner on the XLife project, and what we did with the University of Zagreb, Matt and Tadic did this mostly by himself, with some input from us. But take that as a parallel corpus. Take the logical statements as the foreign language, and take the English statements as the English statements, and learn how to generate this logic from the English statements. And it turns out that because it's a constrained vocabulary, because these are logical statements, so you can verify whether they're somewhat correct logical statements or not, you actually get very, very good output that beats the kind of state-of-the-art that you would get from, say, English to German. Okay. So obviously this is all research work that we're doing, but we found recently we can get something like 75% overlap on the statements that we want to generate from using this kind of methodology. Obviously then we're stuck in PsycL, which you can choose how you want to deal with that, but this is another interesting way in which we can deal with, or we can bridge between, I guess, the classical problem in AI of finding representation for everything and finding the relationships that link these concepts, and trying to do things in a statistical way where everything is a distribution. So this was, I thought, very exciting. And I guess the very final point I wanted to make was this one, which, so an interesting experiment that we ran, we wanted to see how ambiguous the problem is from the eyes of a human being reading a news sentence, so that we could make claims about how hard it would be for an algorithm to achieve the same correctness, or same level of accuracy. So we took 100 sentences from this couple of news wires with stories on business and financial news, and we asked the human evaluators to go through and mark the ambiguous entities where there was missing context. Missing context meaning kind of they tell you something but they don't substantiate it, or they assume that you know. Right now I'm blanking on an example for that. I'll try to find one later. And unsubstantiated references, I mean things like it and he and things like that. But in that sentence, were not substantiated. So we found that 73 of the 100 sentences contained like one or more of these problems. Okay, and we found that in around half of those, we could correctly identify or fix the problem or help the human understand by giving them the document. Okay. Actually, that means that in the other 50%, they needed a much broader knowledge of what was going on than what was available in the news document, which maybe points to the news not being written as well as it should be. At Bloomberg News, we actually have this big book. It's called The Bloomberg Way, and it was written by our editor-in-chief or the director of the Bloomberg News, and it teaches reporters and editors how to write news stories so that they include all of the necessary detail for somebody to understand the concepts that are being written down. Unfortunately, that also leads to the problem at the very beginning of this presentation, which is really long sentences that try to explain everything about the concepts that are being talked about, which is not always an ideal scenario for NLP. Maybe humans, it's like tough medicine. The humans will keep reading it, and they don't like it at first, but eventually it's good for them in some way to have learned these facts about the companies and the concepts that are in use. So, if humans can't do a particularly great job when reading these sentences and understanding where the ambiguities lie and in resolving them, then, how can an algorithm do a better job? So, my final point would be, looking at the entire document as a way of pulling out features that are beyond just the individual phrases and chunks and sentences that we're looking at. Looking at the metadata on those documents, because the metadata you can build models on over time. You can look at the stream, and you can start to generalize from the stream. You can start to abstract away the way that the concepts are behaving. You can start to look at how mixtures of topics, and mixtures of entities and relational types are interacting. You can look at the past history of this concept. You can build models of how things are changing over time. And if you have a richer model of how things are changing, you can start to estimate how likely certain deviations are going to be from that. And you can make better predictions, or you can come up with better explanations for what is happening. So, a lot of what we do when we're solving these problems in natural language processing involves finding the complete set of information that we might want to use to help us. 4:59 a.m. Right? And that's all I got. So I think we've got time for no questions before they kick you out of here.
The bar closes at 8:30.
Oh, Zach, you have a question. Okay. All right. Well, in that case, I appreciate you coming out here. It's definitely good to see that the community is thriving as well. In New York, on the East Coast, I run the New York Knowledge Engineering meetup, which is an interesting meetup, and we have a lot of crossover with the NLP and the machine learning guys there. So if you're ever in the area, you want to shoot me a message, find out about some of the projects that we have ongoing, come and say hi. You'd be welcome to come and meet the research group that I have. A lot of really interesting problems, as you remember from the Costa, the Western, and thanks again.